All right, greetings everyone. It is Mr. Hlajoy here. Welcome to Back to Basics. What we are doing basically today, we are looking at analytical geometry, right? So we are examining again our November 2023 paper. This is going to what? This is going to be the question 4. Okay. Now let's see in terms of how can we go about in attempting these types of questions. The first thing they say in the diagram below, you're having line AC and BD that intersect at B. And also, you are having your AC, which is perpendicular to BD. C and D lies on your y-axis, while A lies on an x-axis. Now, they are giving us the equation of your AC, which is P y subtract x minus 5P is equals to 0. We are also given that you are having your angle alpha, which is your angle of inclination, and also CDB, which is your beta altogether. So both all of those are going to be your angles. Now, for an example, the first thing that they want us to do, they want us to find out what is going to be the coordinates of your C. Can you see when you define your C, you are saying this is your y-intercept, right? And when you're saying this is your y-intercept, you do what? So we are saying for y-intercept, you let what? You let x be equals to 0, right? So which means simple. You can just go back to the equation. Remember, you already have the equation of AC. So you are saying, remember here you are given your y here. This is given by what? You are given by your py subtract x subtract 5p is equals to 0, right? So now we want to find out what is going to be y-intercept. Can you see that? Right, so you're going to say where there is x, you write 0, which means this is same as py firstly is equals to, right? This is py is equals to x plus 5p. Can you see that? And then now what is it that you are going to do now from here? So can you see that here you are going to divide by p, you divide by p, you divide by p, all right? So which means your y is given by x over p plus what? Plus 5. Remember the p and p here are going to cancel each other, and p and here are going to cancel each other. Now, when you substitute the x as 0, this is going to y is equals to 0 over p plus 5. And either or, the answer that you're going to get here is going to be same as what? Your answer that you're going to get here, you're going to get your y as your positive 5. Okay. So which means now your coordinates of your C, your coordinate of your C is going to be same as 5 and what? Or rather, it's going to be same as 0 and 5, right? This is going to be given by 0 and 5, right? So this is 0 and your 5, which is going to be the coordinate of your C. Okay, hopefully this makes sense now. Let's look at the next question. What is it that they require us to do in the next question? They want us to find out, they say if the gradient of AC is half, now they want us to show that P is going to be equals what? They want us to show that P is going to be equals to 1 over, is going to be 2. Now, what is it that you are going to do now from here? You are going to obviously, remember I've already made your y the subject of the formula. I said this equation is given by y is equals to x over what? X over P plus what? Plus 5. And then now, what is it that you're going to do now from here? You are going to what? You are going to come in here and you are going to substitute the gradient of AC. Remember they said your gradient of your AC is equals to 1 over 2. And you remember this equation is given in terms of y is equals to mx, right? Y is equals to mx plus c. So can you see that the mx, right? Can you see that the mx plus c, this represents the what? The mx, right? So which means now, therefore, your gradient already here, your gradient of this is given by what? Your gradient is given by 1 over 2, 1 over 2. Altogether, it's given by 1 over 2. And therefore, 1 over 2 means now here, what? It means now here it's 1 over 2x. Altogether, the gradient is 1 over 2. So which means now here, therefore, the value of this, here it's same as 1 over p, which is equals to 1 over 2. Can you see that? So the value of your p, therefore, is going to be just simply same as what? It's simply same as your 2. Can you see that? Remember here it was x over p. Remember, an x over p is only, it can still be written in terms of 1 over px. Can you see that? Right? So, and your denominator, you're having your 2, and your denominator here, you are having your 2, which means the value of your p is going to be equal to 2. Once again, hopefully now this makes sense to you. Now let's move swiftly along. Let's move swiftly along and see in terms of what else can we do now. So which means already we have the complete we have a complete equation for this particular thing, right? Or for this particular equation. Now let's look at this one now. They say calculate the coordinate of what? The coordinate of your of your beam. Now, how can you go about in calculating the coordinates of your beam? Now, for an example, now what is it that you are given here? There's nothing that you are given here for now. So what is it that you can do for calculating the coordinates of your beam? So now you are going to say already now you have the equation of your ABC. You have the equation of your ABC. And the equation of your ABC is given by what? It's given by y is equals to 1 over 2x plus what? Plus 5. Now, is there any possibility that we find out the equation of what? The equation of your BD? Yes, remember. Remember for equation, it's y is equals to mx plus c, right? Now, remember the gradient of this. This is perpendicular, right? So if this is perpendicular, you can calculate the gradient that is perpendicular. Okay. So you can say the gradient of your AC multiplied by the gradient of your PD is going to be equal to what? It's going to be equal to -1. Because what? Because AC is perpendicular to what? Because AC is perpendicular to BD. Altogether, or you can say it's given, right? Now, which means now the gradient of your BD is going to be equal to what? Remember, this is 1 over 2 multiplied by the gradient of your BD is equal to -1 altogether. So which means now the gradient of your BD is going to be same as your 2. Can you see that? And now that you have the gradient of your BD, you can say now y is equals to 2x plus c. And since y is equals to 2x plus c, you can then now substitute one coordinate, right? You can substitute 0 and -10. And as you are substituting that, what is it that you are going to have? Now from here, you are going to have your coordinate here. You are going to say your y is same as -10 is equals to 2x. And then your value of your c is going to what? The value of your c is going to be, or rather the value of your x is 0 plus c, which means the value of your c is given by what? Your c is given by -10. So which means the equation here is y is equals to 2x minus 10. Now, and can you see that this B is a point of intersection between both of these equations, right? So now you are going to equate these two equations, right? You are going to say 1 over 2x plus 5 is equals to 2x minus 10. Then you are finding out the point of intersection, right? So as you are doing that, what is it that you are going to have here? You can start by multiplying by 2 everywhere so that you can get rid of that denominator of half, right? So it means here you're going to have x. Remember, you're multiplying by what? You're multiplying by 2 over 1 everywhere. So you're going to have x here plus 10. Remember, 2 multiplied by 5 is going to be 10 is equals to, this is 4x minus 20. Can you see that? Now, from here, you can just group your like terms, right? So when you're grouping your like terms, what is that you're going to have here? Now, let's see. Remember this gradient here, it was not just half. Yes. Now, oh, here it's -2, rather. This is -4. Okay. So when you take the -4 here, this is going to be +4, right? So which means you are going to have 5x is equals to what? Is equals to -30. Can you see that? And then now from here, divide by 5, divide by 5. Therefore, your value of your x that you're going to have here, it's going to be what? It's going to be same as -6. So which means the value of b here, it's going to be -6. Your x value of b is -6. Now you can substitute in any of this equation. Let's say you substitute in this one. You're going to say y is equals to 2 into -6 minus what? Minus 10. All right. This is negative. Yes, this is you what? This is going to be same as what? That. And what is going to be the answer that you're going to have here? Now, as you are substituting here, remember your gradient here was negative. Remember your gradient here was negative. So which means now this is same as what? This is same as negative and negative, which is positive, which is 12 subtract 10, which means your y is going to be same as what? Your y is same as 2, which means the coordinate of your b, your coordinate of your b is going to be same as -6 and your 2. Can you see that? The coordinate of your that is going to be same as -6 and also your 2, right? Hopefully this makes sense to you now. Let's just continue now and find out what is it that you are having also from this particular question. what else is required by from this particular question? Let's just make up our space here. Now let's just scroll upward, right? Yes, let's just scroll upward. Now, what is it that you are having now from here? Now, in this other question here that you are having, you are given that you have what? They want us to calculate what is going to be the angle of alpha, right? So now, in order for us to calculate alpha, let me just erase most of these, right? Now, remember your alpha, it is an angle from here till here, right? Okay. So in order for you to calculate the angle of alpha, you need to know what is the gradient of AC. So you're going to say your tan of theta, or rather your tan of alpha in this case, your tan of of alpha is going to be your gradient, right? And not just any gradient, but the gradient of your AC. And then what is going to be current of your AC? This is same as your tan of alpha, which is equals to 1 over 2. Then which means your alpha here is going to be same as what? Shift tan of 1 over 2. And then the current that you're going to have here, it's going to be same as 26 comma 57 degrees, right? 26 comma 57 degrees. So which means this is going to be the angle here. 26,57 degrees. That's going to be your angle of what? Your angle of inclination for your alpha. Right now, they say hence or otherwise prove that A, B, C, D is your what? Is your cyclic quadrilateral. Prove that A, B, C, D is your cyclic quadrilateral. Now, how can you prove that this is your cyclic quadrilateral? Remember, in order for you to prove cyclic quadrilateral, you need to prove two things. You need to prove that one, either the opposite angles are what are remember from cyclic quadrilateral, it's either the opposite angles are supplementary, right? The opposite angles are what are supplementary, or what, or rather the exterior angle, the exterior angle of your cyclic quad is equal to the interior opposite angle, right? So now what is it that you can start doing here? For an example, let's say you're starting with your what? Let's say you are looking at your angle ACD, right? Let's say you start with your angle ACD to find out what is going to be this particular angle here, right? Now, to find out your angle ACD, what is it that you can do? Now, remember here, it's also your 90. So if you are looking at your triangle AOC, AOC, now you're going to find out that now your angle ACD, your angle ACD, let's say, yes, we are using ACD. Your angle ACD, can you see that now this angle is going to be this one plus, it's going to be 180 degrees subtract 90 degrees plus what? Subtract 90 degrees plus 26,57 degrees. Can you see that, right? And then now, as you are doing that, what is it that you're going to have? Your angle, the reason from here, it's going to be what? Interior angles of a triangle. Interior angles of what? Of a triangle. Can you see that? And then now, which means your ACD is going to be same as what? It's going to be same as 63,43 degrees. Can you see that? Right? Then that's basically going to be your angle of ACD. And now that you're having your angle of ACD, I want us to do what? I want us to also calculate what is going to be your angle of what? Your angle of your beta. Now you can calculate your angle of your beta, because if you can look at BCD, right? If you can look at triangle BCD, you can calculate what is going to be your beta, right? Or even if now, how can you calculate your angle of your beta? Now, to calculate your angle of your beta, what is that you're going to do? You're going to say here, your beta is going to be same as 180 degrees subtract what? Subtract your 90 degrees plus your angle C here. You already found it to be what? To be 63,43 degrees. Can you see that? So therefore, which means your angle beta is going to be same as what? It's going to be same as your 26. Oh, the reason here it's still going to be the same interior angles of a triangle. So this is same as 26,57 degrees, right? Now, I want you to look at something. Can you see that? Now, if I draw my cycle in here, or my circle in here, right? Now, what is it that you know? Can you see that this This one and also this one are going to what? This is going to be the angle, you know what? The angles in the same segment. So from here, can you see that your angle alpha is equals to your angle beta? Okay. So which means now, if your angle alpha is going to be what? It's going to be equals to your angle beta, then this is going to what? You can conclude that your A BOD is a what? Is a cyclic quad. Why are you saying this is a cyclic quad? This is because of what? Remember, this is a converse of angles in the same segment, right? Converse of angles in same segment. Same segment. Basically, that is going to be the what? That's going to be the reason behind that. Can you see that? So basically, that is going to be that particular angle. Hopefully, this makes sense to you now. Let's look at the last question, 4.6, right? We are looking at the last question, 4.6. And then from there, we are going to see in terms of what else now can we do? In 4.6, what is it that they want us to do? They say determine the coordinates of the center of the circle where which pass through a BDC. BDC, which means now if they are having another cycle that is passing in here, right? Let's say BDC. This is C, this is D. I know my cycle is not looking, appetizing enough, but I think you can see the idea, right? So now what is it that you can do now from here? They want you to calculate what? They want you to calculate what is going to what? The coordinates of your center. And when they say coordinates of your center, they want you to calculate what is going to be the coordinates of the midpoint. Now, what is it that I want you to take note of? Now, let me just remove these other diagrams nicely so that you can actually follow here. All right. Let me just remove these other diagrams nicely here. And then I draw this circle of mine nicely here. Yes. Hopefully you can see that. Now, I want you to see this. Can you see that this forms a what? It forms a what? Your angle in your semicircle, right? And the angle in your semicircle, it forms what? Forms a 90 degree. Can you see that? So now, and when this is an angle in a semicircle, it makes this to be your diameter. Are we together? And if it makes this to be your diameter, right? Remember, we must say firstly your B your what? Your BD, or rather your BD, right? Your BD, rather, not BD, rather, but your BC. Look at me, your DC, look at me. DC is a diameter. Is a diameter. Why are we saying this is a diameter? Because it's it's a line subtended by what? It's the line subtended by a 90-degree angle, right? Can you see here you have a 90-degree angle, right? So basically that is going to be that. Now, so which means now we are looking for the midpoint of actually your D and C. So if you are looking for the midpoint of your D and C, you must just use the coordinates of your what? Of your C here. And remember the coordinates of your C was what? Was 0 is to 5, if I'm not mistaken, right? So which means now this is same as X. This is going to be same as your X of C plus your X of what? Plus your X of your D divided by 2. This is going to be your Y of your C plus your Y of your D divided by 2. And then now from here, what is it that you're going to have? Here, this is going to be same as 0 plus 0. Can you see that this is same as 0 plus 0 over 2, which is same as what? Which is same as 0. The other one is going to be same as what? The other one is going to be same as 5. This is same as 5. 5 plus negative 10 divided by 2. And then what is going to be this one? 5 plus negative 10 divided by 2. This is same as what? This is going to be same as 5 over 2, if I'm not mistaken, right? The answer that you're going to have here, it's going to be same as negative 5 over 2. Negative 5 over 2. So basically, which means the coordinate of the midpoint that you are finding here, it's going to what? Negative 5 over 2. Hopefully, this makes sense to you now, and you're in a position to answer all these types of questions. Thank you very much.